Hello, everyone. In this week's Hewlett Packard's Lab podcast from Research to Reality, I have a great honor and pleasure to host Tiffany Jarnigan and Colin Bash. Hello.
Hi.
Hello, Dan.
Today we'll be talking about sustainability. It's an interesting topic. How did you get interested in it the first time?
You want to go first?
Well, for me, I by background, I'm a mechanical engineer, so by training, and I guess I got professionally interested in sustainability when we started looking at energy efficiency, and got interested in how to improve energy efficiency of different types of systems, and from there just sort of slid into sustainability because it's not too far to go from conserving energy to conserving other types of materials and resources.
So I actually started becoming interested in sustainability when I started working for a company in San Francisco that did or does distribution of organic fruits and vegetables.
Nice.
And it's a woman-owned, run, founded company in San Francisco that was really critical to the sustainable food movement around California. And they do distribution all around the Southwest. And so I really came of age at that company. And it was there that I learned that companies could be sustainable and responsible, and that it didn't always have to yield to compromise. And so.
Very nice, very nice. And we jumped discussing sustainability, we haven't even defined it. So how do we define it?
So it's a word that I think people are throwing around a lot these days, and I think it gets conflated with the term ESG. So you'll hear sustainability and you'll hear ESG, but I think at its most basic, sustainability refers to the ability for businesses to operate responsibly from an environmental and a social perspective. I think it's fundamental. And it's had to be sort of an external factor that's forcing companies to think about sustainability because that true cost is not reflected in how we measure economics and how we think about growth and how we think about prosperity.
So the whole spectrum, really.
Yeah, and I like that way of thinking about it. And for me, the way I think about sustainability is it's a balance between environmental impact and economic impact. Mm-hmm. And for far too long, that balance has tilted away from environmental impact and more towards economic impact, where environmental impact has taken the brunt of the harm, right? And so a lot of what we need to do to get back to sustainable operations is rebalance that. Yeah. And we need to do it in a way that allows economic growth and that allows environmental growth. The other kind of way I think about it is do no net harm. Yeah. If you're going to do some harm, then we have to find a way to make sure we make that up in some other way. And this theme of no net harm is going to come up over and over again, I think, in this discussion.
Yeah. It's almost like family constellation of technology.
Yeah.
You mentioned that we worked on it for some time, but then suddenly it wasn't as popular. But all of a sudden, again, it's extremely popular. Why is it so?
I mean, if you talk to folks like Colin, who will chime in about this, they talk about sustainability and how it's ebbed and flowed over time, right? I came to HPE 4 years ago, so for me, it's been a steady increase over time. And I think that there's kind of a confluence of multiple factors happening at this time. So there's increasing stakeholder expectations and demand for companies to operate sustainably. So companies are feeling that from their shareholders, from their investors, from their employees, from their customers. Which is really causing companies to come up with more ambitious and audacious goals like commitments to net zero. And those are things that you can't walk away from. And so I think that it's signaling to folks who have been through this before that now it's more serious than it's ever been.
We were working on sustainability. We had a focused effort on sustainability at Hewlett Packard Labs until about 2013. And which doesn't mean we didn't stop thinking about it or working on it. It meant that it kind of blended in with some of the other things that we were doing. And in 2015, the Paris Agreement was signed. 2 years after we sort of started working on other things. And that meant, and what they did at the Paris Agreement is they set 1.5 degrees C as the limit for temperature rise from the time of the Industrial Revolution to minimize the largest impact of climate change. Yeah. And shortly after that, in 2018, a group of government panel folks got together and said, all right, if we're going to limit it to 1.5 degrees C, then to do that, we have to limit carbon emissions and get to net zero carbon emissions by 2050, over 2018 levels, and then have them by 2030. And so these are the goals that Tiffany's talking about now that corporations are starting to make. People are starting to pledge these goals of how we're going to get to, as a corporation or a company, having emissions by 2030 and then eliminating them, or getting to net zero emissions by 2050. So that's what's really changed. And that's why there's an overall focus now, not just within HPE, but globally on this notion of not just sustainability, but getting to net zero carbon.
Yeah.
So we were yet another victim of being ahead of our times, but at least we're ready now.
Yeah.
That's the definition of research.
Yeah. Speaking of research, what are the key contributors towards sustainability or away from sustainability?
Well, I think when we think about reaching that carbon neutrality goal, there are a couple of ways we can get there, and these are broad topics. Think of them as broad knobs that we can turn. And one knob is reducing demand for energy. Right? So if we reduce demand, then we don't need to emit so much carbon. And so that's one. But the other one is to reduce reliance on fossil fuels and increase reliance on renewable energy sources. So that's another big knob. And then a third knob is, can we produce things that are longer lasting? We kind of call that the circular economy, or can we contribute to circularity? Yeah. Can we devise systems that are reusable, or that are recyclable and that have longer lives? So that helps. And then a fourth one, and I think there are really probably truly four, is carbon sequestration. So how do we remove carbon from the atmosphere? So those are kind of the four things that we tend to look at. And then within those things, there are a number of technologies that are pushing us forward in the right direction. And then there are a few industries that are pulling us away a little bit. And so if we think about reducing reliance on fossil fuels and increasing renewable energy, there's been a lot of interest recently in what we call distributed energy resources, or DERs, as we like to call them, because we have to turn everything into an acronym. And so DERs are basically just microgrids of energy sources, and they tend to be renewable energy sources. So think about photovoltaic arrays or wind turbines and things of that nature. And those sources are all intermittent. And so a challenge is how you connect those into the public utility grid, the larger grid, and scale them out. Because ultimately we need to scale out and start replacing fossil fuels with renewable energy. So that's sort of one technology or one area of focus. The other is energy storage, which is kind of two sides of the same coin. If we have intermittent sources, then we need a way to store that energy to use it when those sources aren't available. And what's interesting is that there's been a lot of work in chemical energy storage over the years. So think lithium-ion batteries and that nature. But there's more work now being done in alternative energy storage means, so gravitational energy storage. If we can lift something up, a heavy weight, and then lower it down slowly, we can capture, turn that potential energy into electrical energy if we hook it up to a generator. Same is true with pressure vessels and things of that nature. So people are starting to look beyond just chemical storage. And then transportation, right? Electric vehicles is kind of the big other button that we can turn to reduce emissions, particularly in transportation systems. And that's interesting for the grid too, because those sources put demand on the grid at different times of day than what the grid is used to, because they're mobile. And then carbon sequestration, I mentioned that, but we're not going to get, in 2050, we're not going to get to zero carbon. We're going to get to net zero carbon, which means that we'll still be emitting carbon, but we'll need technology to remove what we do emit from the atmosphere. And right now, we don't have a scalable means of doing that. And so that's sort of a big open area that people are starting to look at. On the forces that are pushing against it, The one thing I like to pick on, it's got kind of a big bullseye on its forehead, is Bitcoin mining. To mine Bitcoins requires a lot of energy because these cryptographic hash algorithms are hard to solve. They're not very efficient. So can we look for means of improving the efficiency of those algorithms to reduce energy consumption in Bitcoin mining altogether? We can kind of go on and on. There are challenges in the construction industry with cement and concrete, and the use of alternative materials, building materials. One thing that's interesting about sustainability is that there are no easy answers.
Yeah.
And things like concrete emit a lot of carbon into the atmosphere. They use a lot of water, uses a lot of resources, but it's a really good building material, and we use it to build dams and reservoirs that then generate energy hydroelectrically. So you sort of have to look holistically at all of these problems.
Very interesting. So you spoke about many verticals. Let's focus on IT. I heard about IT for sustainability. I heard about sustainable IT. Are these two the same, different, related, unrelated?
We kind of see them in terms of spheres of influence. So if you think about where HPE is, we're talking about sustainable IT. We sell IT gear. We have the ability to help our customers think about the sustainability of that IT environment from edge to cloud. And then once you start to think about then how do you transfer the application of that technology for sustainable purposes, and then you start to branch out into some of the themes that Colin was talking about. And I know that that's an area you're particularly passionate about, so.
No, I appreciate that answer. I think that kind of nails it. And so for sustainable IT, it's really about over the life cycle of IT, from the design side to the manufacturing side to the use phase to the end of life. How can we reduce carbon? How do we improve energy efficiency? How do we reduce the amount of materials that we need in these devices? So for sustainable IT, if we start with design and manufacturing, can we develop methods to reduce overall embedded carbons, kind of how we talk about it, the carbon that's embedded in systems due to the energy that's used to fabricate those systems, to operation and then to end of life. And we talked about circularity already, but that's a big part of end of life. How do we extend the life cycle of IT equipment through upgradability and other means?
Yeah.
IT for sustainability is where there's huge need, I think, and huge potential benefit for getting us to net zero carbon, right? Because there's only so much we can do with IT equipment, but if we apply that to other areas, other ecosystems, there's potentially a large impact. I'll give an example of some work that we're doing in our AI research lab at Labs. This is work with Carnegie Clean Energy. And they're a company out of Australia. They build these huge wave energy converters. They sit on the ocean floor and they take energy from waves and they convert that into electricity. And they came to us and they came to researchers in labs asking for a better means of controlling that system so they could maximize energy production and minimize the overall cost of operations. And so our AI research lab is doing work on reinforcement learning. And so we thought, well, let's try to apply reinforcement learning as a different kind of controller to this sort of system. And we were able to do so and maximize their energy output while minimizing overall stress on the system, which minimizes maintenance costs. So it's a really good example of kind of IT for sustainability. And another one that I'll touch on, because I think we'll bring it up a little bit later, is digital twins. And so this is getting more and more attention, and this is really about building a model, digital model, of a physical system that lives and evolves for the life cycle of that physical system. So that we can then use that model to optimize various different aspects of operation of that system, including energy consumption and resource usage. And in some cases, depending on the model, maximize use of renewable energy.
So Colin mentioned one clean source of energy using waves. Are there other clean sources? Can Mother Earth help us in any other way?
I mean, I think that, the most common ones are solar, wind. Those are the ones that have proven to be most scalable. I think we run into issues when we start talking about materials required to build those types of renewable energy. There's fuel cell technology. There's geothermal. They use that actually a lot for data centers in Iceland, right? Trying to think what other ones are truly scalable.
That's the issue, right? The issue is always scalability, and what source of energy. There may be a lot out there. Our Mother Earth, as you call her, has we live in this solar system that is given birth by the sun, right? That's providing a huge source of energy, and so photovoltaics can capture that. But like Tiffany said, it gets back to embedded energy that we were talking about, and embedded carbon.
Yeah.
So we may, in the use case for solar photovoltaics, look at that as clean energy. But if those cells were fabricated using dirty energy, then they have a lot of embedded carbon in them.
Yeah.
So and they are intense. They take a lot of energy to create a photovoltaic cell.
Yeah.
Wind turbines, we're looking at how that can scale now more and more. We're looking at offshore wind turbines, right? Because there's a lot of wind available offshore. And then in terms, we talked about the wave energy converter. That's potentially scalable, but it's going to be limited to real estate next to the shore, right? And so that's by definition limited in terms of where you can place it. And the ocean environment is incredibly harsh. Maybe we'll talk more about that later, but
I think
maintainability.
That's why what he was talking about before with the distributed energy networks is so important, because there is I think that's sort of the fundamental piece of sustainability, is that there's no silver bullet. All of these problems are incredibly complex, and I think that they require sort of an ecosystem of support in order to solve them, right? So it won't be a singular source of energy that we'll have to replace fossil fuels. It will be a combination of multiple sources that are managed in a way that allows for the type of flexibility and availability that we're used to.
So none of these are really easy to get to. How can technologists help extract that energy?
This may be the most important thing we talk about, because we have a dearth of human capital in this space. Sustainability is a very broad area, and like there isn't one energy source that's going to help us, there isn't one area of expertise that's going to help us. It's going to be pretty much everybody. So if we think about where technologists can help, we need mechanical engineers, electrical engineers, computer scientists, control theorists, chemical engineers, even biological engineers. And so if there are people listening that are interested in sustainability and they have a technology background, I can almost guarantee that what they're working on is in some way or another applicable. Well, I'll give you some examples. And this came from a conference that we were the three of us, at a couple of weeks ago, where we were talking about software development and application development, and how we need tools to allow software developers who are writing applications to understand the impact that their decisions is having on overall energy consumption of the hardware that application is running on. Today, those tools don't exist. But if they did, then these developers can start making trade-offs about algorithm development. We talked about Bitcoin mining. To help be part of the solution, right? And so think about broadly. Another I think area that's really important is cybersecurity, right? So if we think about adding and extending IT to sustainability and helping us defossilize or decarbonize the grid, right? We are now adding more attack surfaces on the grid, and so we have to start thinking about security from the ground up when we think about solutions. So technologists can help in many different ways. Those are just two examples, but there are many, many others.
So clean energy is more likely target for cybercrime than the one that is not clean.
The one that's not clean is also a target. I think everything's a target, and if we make the entry easier, then that target's going to get bigger, right?
Speaking of theft, Colin was talking about technologists. What about legislature? It appears to me that there's a huge opportunity for governments to control, regulate, help us.
Yeah, I think we have to be careful, right? Because I think policy can only do so much. I think that there's a lot of responsibility that businesses need to take for themselves as well. I think a few areas where policy and legislation can be helpful is around particularly access to renewable energy. if we can make it a lot easier, either through legislation or through some type of stipend programs, for us to be able to scale renewable energy into particularly areas that don't have availability of that right now, whether that's in areas where the government isn't particularly supportive of it, or there's not broad availability of funds to build that type of infrastructure. Private business has been really important, I think, in the scaling of renewable energy sort of globally. But I think if policymakers and different country individuals were more supportive of that type of infrastructure development, I think that that's going to be really important, because largely, I think in order for us to decarbonize and to hit our 2050 goals, the grid is going to have to be decarbonized. Because when we think about like HPE, for example, and we think about our footprint, about 35% of our footprint is upstream. So that's all of our suppliers and everything that they build all over the world. And 60 to 65% is our downstream. That's all of our customers using our products. And so when you think about the distribution of the consumption or the distribution of the carbon emitted as a result of our products, it's truly globally. So HPE can only do so much. So I think that that's one area. And another area, and I know this is sort of the third rail of sustainability, but is, again, going back to the first theme that we talked about in terms of the balance of environmental, social, and economic sustainability holistically, is we need to start accounting for the cost of the true cost of doing business. One way to do that is through a carbon tax or some type of carbon fee that makes companies accountable for the carbon that results from their doing business. I think that the danger there is that type of cost runs the risk of ending up with the consumer, and that's not fair. And that's not going to be socially economically viable, right? If we pass all of those costs down to the end consumer, what does that really mean, right? And who should really be accountable for it?
Yeah, I too share concerns about governments getting overly involved, because we know that people don't like that. They don't like to be told what to do necessarily. But at some point, if we're going to get to net zero carbon, there has to be a role for government. So, what is that role? And Tiffany laid out, I think, a really great role for them to play. I think about electric vehicles, which I don't own one yet, because I'm afraid that I'll get stuck someplace. And so whose responsibility is it to build out the electric vehicle charging infrastructure in, say, California? And can the government help with that in some way or another? Yeah. And in California, they're working on, I think the legislature is working on a mandate that by 2035, there can be no more internal combustion engines sold in the state. That probably can't happen without some kind of government mandate, right? And if we're going to get to net zero carbon, we probably need to decarbonize our transportation infrastructure, because that's a big part of it too. The other thing I'll add to this is getting back to carbon capture. Where the government can help also is in funding fundamental research to help us accelerate and de-risk technology that we know we're going to need to get to net zero. And I see sequestration and carbon capture as being kind of a prime target for a lot of this. The government's been funding work, and they are funding work in this area, but they've been funding work in renewable energy for decades. Right, and now we need to start looking at that, but also expanding that to other.
But you were working, I remember, on net zero data center 10, 15 years ago. What other projects did you work on at that time?
Well, I was working on those projects, but that group, I was part of a much larger team, and so that team was, going back to the human capital question, that team was comprised of people with a number of very different backgrounds, different areas of expertise. And it was led by our senior fellow at the time. His name was Chandrakant Patel. He is at HP Inc. Now, still a senior fellow. But he and I had been working together, along with others, for a long time on how to cool computer systems. So I think I mentioned some of this earlier, and that extended into the net zero energy data center. But the thing that made that interesting is that what we were doing was blending various different control systems together. So we were combining cooling control systems with the control of IT systems in the data center. And we were working on placing workload in the data center in areas that were more efficient to cool. And then we connected that whole data center, and this is something we actually built, to a photovoltaic array. And we started doing demand shaping, where we matched demand for energy in that data center with the availability of solar energy on the photovoltaic array. And we got to net zero energy, like you said, not net zero carbon, but net zero energy, because energy is what we were focused on back then. But then we started looking at, all right, how can we take this idea of integrated supply and demand and extend that out to other ecosystems like buildings and cities? And so we started kind of laying the framework for that work. And what we discovered, which was interesting, I think, is that a lot of the work that we had done in the data center space, whether it be devising new energy efficiency metrics or reporting tools, that was extensible to other ecosystems. So that sort of got us thinking about this whole IT for sustainability space.
Tiffany, how have things changed since Colin worked on it 10, 15 years ago?
You know, it's a really good question, and I kind of had to laugh when I saw that on the list. So I think what's changed is I think businesses are ready now. I think when Colin was working on that research, the business case was not quite as compelling as it is now. And I think that there was still the broad misunderstanding, perhaps it was true at the time, but the broad misunderstanding that if you wanted to be sustainable, it was absolutely going to cost more money, and therefore not a worthy investment unless the business was doing really well, right? So sustainability was kind of popular when the times were good, and then it was the first thing that got cut when the times were bad. So what we're seeing right now is we're seeing more investment and more signals from the EC and from top level management around sustainability initiatives than we've ever seen before. We've got folks at the top directly involved in our work, overseeing our projects, really supportive of the programs that we're trying to drive. And so it's given us the opportunity to reconnect with labs and to say, dust off your research from 15 years ago, the time is now.
So the other difference, it appears to me, is that in the past, Colin, you were focused primarily on data center, but now we also have edge. Mm-hmm. So what do we do now? And edge, even though small, there's lots of edge. So are we focusing still on cloud, data centers, or edge, or both?
I think we're focusing on both. And we talked about the energy grid, and we talked about distributed energy resources, and some of the things that we could do to use IT to help us optimize and manage those resources. All of that is the edge. The energy grid is at the edge of the network, and so by definition that's going to be an important part of the solution. And then cloud data centers, we also talked about digital twins, and if they're big enough, they're going to reside in the cloud, right? Or they're going to reside on a supercomputer, depending on what it is they're modeling. So imagine a digital twin that is modeling some portion of the energy grid. Mm-hmm. Wherever that's residing, let's say it's the cloud, is going to have to connect to the edge, the energy grid, for updates and for communication. So connecting the edge to the cloud or the edge to the data center is going to be where we need to focus.
What is HP doing to help in this whole situation with sustainability?
It's a good question. So what I can say, because I think our Living Progress report or sustainability report will be published by the time this comes out. So we're announcing, maybe have already announced a suite of net zero goals for HPE. And there's a really great team, sustainability team, broader, that worked tirelessly over the last 9 months to put that together and to make sure that we're modeling our projections correctly according to growth, and that it would be something that we could achieve, right? And it received full leadership buy-in. And so we've got a suite of 2030 goals where we have committed to reduce 70% across our Scope 1 and Scope 2 emissions. And then for Scope 3, 42% by 2030. And then by 2040, we're going to hit net zero, which means a 90% absolute reduction. And then the remaining 10% under SBTI guidelines can be through offsets or removal, but that initial 90% has to be an absolute reduction. So that's just our suite of net zero goals. And then more broadly speaking, I had mentioned that we've got more leadership support than ever. And so I've put together a couple of working groups that Labs is participating in. Colin's in a working group that we have around sustainability offerings to think more critically about what types of holistic sustainable solutions are we bringing to market to solve our customers' problems.
Very, very nice. So Colin, you put on the spot. What is your working group doing to help?
Well, our working group is looking at how we can push sustainability initiatives into product design and into solutions, and so which is a hard problem because we talked about sustainable IT, right? And what we can do to make IT more sustainable, and there are a few knobs we can turn, but we have to be careful about making sure that we're again striking that balance between business need and sustainability. You know, one thing I'll say just to give kudos to the company is I think it was 3 weeks ago now maybe we announced the Frontier supercomputer at Oak Ridge National Lab. And that computer is the highest performance system in the world at 1.1 exaflops, which is a billion calculations per second. But maybe more important, you know, we talk a lot about efficiency, but performance with efficiency is really important too. And this is now number one in the top 500 list of computers, but it's also number one on the Green 500 list of computers at 62 gigaflops for one rack of machines, 62 gigaflops per watt, so 62 billion calculations per second per watt. So, you know, what we're doing as a company is developing technology that sure should be energy efficient, but if it's not doing useful work, then we shouldn't be in business, right? So if we can show that we're doing useful work and we're doing it in an energy efficient way, that's a win.
Can the rest of the community, for example, professional organization and everybody else, help in this effort?
So professional organizations are really good at bringing together people within government, within industry, within academia that have similar areas of expertise. And I think there's an opportunity going forward for professional organizations to get together, and we talked about sustainability being broad, sponsor workshops or conferences that bring people together of maybe mixed backgrounds so they can start tackling these multidisciplinary problems. ASME and IEEE have done this in the past for electronics packaging and cooling solutions, and it works very well because you get to mingle mechanical engineers, electrical engineers, computer scientists together to start working through solutions to these problems. Sustainability needs something similar. Professional organizations can absolutely help.
And Tiffany, do you think there's any need for standards in this area?
Oh, standards is always a really tough question. I mean, I think that there needs to be a minimum level of scrutiny in terms of the definitions of what we're all committing to, for example. Like, I think that it's absolutely essential that when we're committing to something like net zero, that there's a common accepted standard definition that everybody has to adhere to, or they cannot make the claim. I think that there's a lot of room for organizations to make, perhaps not purposefully, but claims that are just not true. And I think what it ends up doing is it confuses the public, and I think it confuses the issue. And so I think that standards do play a role. But then, when you think about a company like HPE, where we're enterprise technology, should we be held to the same standards as a consumer-grade electronics company, for example? Should we have to be held to the same standards as HP Inc. when it comes to certain sustainability commitments, or certain Energy Star commitments, or energy efficiency of our products? Certainly, you can't compare a server with a laptop. And so I think there is a place for standards, but I think we have to be careful about how we use them.
Great observations. Do you, Colin and Tiffany, think there are any mega trends that flow together with sustainability?
Well, one mega trend that's getting a lot of publicity today is the metaverse. And we can look at that kind of from both sides of that coin. On the one side, there's a lot of promise. If we think about digital twins again, they may sit in this metaverse. And so you think about a metaverse as a way to map physical reality into digital reality, and then use that digital reality to optimize the physical reality. So there's potentially quite a bit of benefit there. I worry that as we move our physical lives into this digital metaverse sphere, that we're consuming a lot more energy than we would otherwise. And so we have to be careful about, again, what's that balance? As we build out this metaverse, because it's new, it's a new idea, we have a lot of opportunity to think through how we build it and make sure that what we're doing is having a net positive and not a net negative. So don't net harm, right? Gets back to that.
So sustainable digital twins, that's what we need. I usually end on a personal note. How do you lead sustainable work-life balance, Tiffany? What do you do outside of work? Because I know you work day and night on sustainability.
Well, I'd say the most sustainable thing that I did recently was I moved out of the San Francisco Bay Area. So I went from spending a significant amount of time in my car, commuting back and forth between San Francisco and San Jose, commuting over to the East Bay for extracurriculars, going up north for hikes, and I moved to a smaller community in northern Arizona, where
nice.
I barely use my car at all.
Beautiful.
So, I haven't done the back of the envelope calculation to figure out, how that has exactly changed my carbon footprint, given that I went from a 450 square foot apartment to, a 1,500 square foot house. But, I'd say that was probably the biggest change recently.
Beautiful. And Colin, I heard that you were less interested in driving and much more in diving. Is that true?
Well, yeah, I've been a scuba diver since I was 16. And the reason is because I grew up in San Diego. And my North Star, my compass, was always west. It was the ocean. And I never lived on the ocean. I lived within about 20 or 30 miles, but I always knew where it was. It's really weird as a kid growing up near the ocean. You always kind of set your compass towards that. I wasn't the only one to do it. And so, yeah, I'm interested in scuba diving, but what got me interested in sustainability as a kid was marine biology, which is why I wanted to become a scuba diver. I wanted to get up close and see the strange creatures in that alien world under the sea. And what got me interested in that was the undersea world of Jacques Cousteau. If you're not old enough, Google it. And we didn't have a lot on TV back then. But we did have Jacques Cousteau, and he would take us, underneath the water and share the ocean world with us. He was also the inventor of the aqua lung, which is the regulator that we use in scuba diving. But he would always end his specials with a note of caution about humanity's impact on the oceans, always. About overfishing, about pollution, about coral bleaching. And so that got me thinking about, all right, what can we do to help? And to end on a positive note, because I don't want coral bleaching to be the last thing you hear. I think all this talk about sustainability and getting to a carbon neutral place. We can look to your Mother Earth, our Mother Earth, for inspiration on how to do that.
Indeed, very inspiring. Thank you very much for this beautiful summary of sustainability.
Thanks for having us.
Thank you.